Hello everyone and welcome to this video. Today we'll be going through one of our projects on machine learning. We are a team of three consisting me, Vanshika Gupta, and my colleagues Aneerban Chaudhary and Shikha Soni. In this project, we have collected data from American Express Challenge that happened from May to August 2022. This project is based on different features of customer behavior in which we are trying to figure out whether a customer will repay his credit card bill or not. It is a case of binary output, therefore, we are using two approaches. One is logistic regression and the other one is KNN. So I'll be explaining each step one by one how the code is working. So, first of all, we start by importing all the necessary libraries. These libraries include NumPy, Pandas, etc. So, Panda is used for data manipulation, scikit-learn is used for model selection and metrics, Seaborn and Matplotlib is used for visualization, ScorecardPy for calculating IV, which is a feature selection method. Now, in the next step, we are trying to load the training and testing data. Here we are reading data from feather format files, which helps us in efficient and fast reading and writing. We also load the labels separately from a CSV file. We are using feather objects as they are very fast, lightweight, and easy to use binary file format for storing data frames. Now, once data is loaded, we start with the basic exploration. We check the shape of the data set and display the first few rows using the head function. This gives us an idea about how the data looks like. Quick count plot of the target variable helps us understand the distribution of the classes. This is useful when we need to see if the data is imbalanced. Next, we start preparing our data. We convert the S2 column, which holds date values, into a proper date time format. Then we reduce the data by selecting only the most recent entries for each customer. So, this step ensures that we are only using the latest information available for our predictions. Now, in the next step, we merge the training data with the target labels using merge function. Then we prepare for feature selection by identifying which column to drop, such as customer IDs and date column, and which are categorical features. Next, we ensure that all categorical variables are properly labeled as category type and rest of the features are converted to float32 to save memory. It is important using correct data types for memory efficiency and better model performance. Now we calculate the information value or IV. This helps us to understand the predictive power of each feature. Using the scorecard pie library, which we have imported earlier, we calculate IV for all columns and store the result in a dictionary. We then save this dictionary in a JSON file. IV or information value is one of the most useful techniques for selecting important variables in a predictive model, and it helps to rank the variable based on their importance. So, let's say if the IV is less than 0.02, then the predictor is not useful for modeling. If it is between 0.02 to 0.1, then the predictor has only a weak relationship. If it is in between 1 to 0.3, then it has a medium strength relationship. And if it is 3 to 0.5, then the predictor has a strong relationship to the good bad odds ratio. Now, for selecting feature, we are calculating IV values for each feature. Now, to continue the explanation further, I would like to hand over to my friend Aneerban.
Thank you, Vanshika, for the wonderful explanation. Vanshika has covered up to the part of saving it into a JSON file. Now, the reason why we saved it in a JSON file is, as you can see, the code computation took a lot of time to find the right IV value. So now, once the value calculation is done, we can store it in the JSON file and we can import it directly whenever we want to use this code without running the IV calculation part. So here you can see if I want to run the code again, I can directly use that JSON. I can directly use that JSON and I can directly import it and use it further. So let us see how to use it further. So whatever value is calculated, I convert it to a Panda series and it is stored in a data frame. And then the same is sorted on the descending order of the features. Now let us see what the next part of code does. So this code is designed to select and visualize the top features from a training dataset based on the information value, that is the IV, and their correlations. Now, this line selects the value where the IV score is greater than 0.5, and then it filters the categorical columns and the training columns to keep those columns which are present in the selected features list. Further, we take top 20 features and plot a correlation matrix. A correlation matrix is a statistical technique to evaluate the relationship between two variables in a dataset. And here you can see this graph for the same. Further, we define a function that is drop feature selection, which compares the IV score of two features that are the input parameters row and col, and it drops the feature with the lower IV score. If the IV score of the feature in row is greater or equal to that of feature in the call value, it will return call. Otherwise, it will return row. That means row will be dropped in this case. This further, this line computes the absolute correlation matrix of the above chart that we saw, and the result is stored in a correlation matrix. This extracts the upper triangular matrix using np.triu function, and the upper triangle represents the correlation between features without any redundancy or duplicity, as the correlation matrix is symmetric in nature. The next line shows the upper triangular matrix in a long format where each row represents a pair of feature. Further, we drop the duplicates and sort the values accordingly so that the most correlated feature appears first. After this, from this line onwards, we filter out the feature pairs that have a correlation lower than 0.8, and we keep only highly correlated pairs. Further, we map the information value scores from the dictionary that we stored above, and uh, we map the value to the corresponding features in the row and column of the this of CORR underscore DF variable. Now, when I go ahead, when we see this part, this area extracts the unique features marked for the remover from the previous step where highly correlated features were identified, and with the one with the lower information value that was chosen to be dropped. Now we split the train and test data using these two lines. We split the test and train data into 70 and 30% split, and with a random state that ensures that the split is reproducible. We keep this random state as 42. We can also keep it as 0 as well, so that whenever we run the algorithm again and again, we'll get the same set of test and train data split. Post that, we will remove those features, those uh, that are not part of the set that we did while calculating the IV, and we only keep the important features further. When this part is done, we divide the data into train and test and the valid area, and this is done here. Further, we could see there were some data parts where the column value were null or were blank. So we imputed the data using a simple strategy of mean imputation. So here the mean imputation was done to fit the data wherever there were blank values. Now I would like to give hand over to Shikha to further explain the machine learning algorithms that are logistic regression and KNN.
Thank you, Aneerban. Um, so I would like to discuss about the logistic regression and the machine learning techniques that we are using in this project. So first, I'm going to discuss about logistic regression, which is nothing but is a method used for binary classification task, and it estimates the probability that a given input points belong to a certain class. Either it is 0 or it is 1. The function used by logistic regression to map predicted values to probabilities is the sigmoid function. Here, now we are going to initialize our logistic regression model. So we are going to use maximum iteration as 1000, which sets the maximum number of iterations the algorithm will take to coverage. Sometimes for large or complex data sets, logistic regression might need more iterations to find the optimal solution. Then we are setting random state as 42. This ensures reproducibility by controlling the randomness involved during the model training process. Here we are also now, once we had initialized the model, we are going to train our model by using a fit command, which command trains the logistic regression model on the training data set. X train for features and Y train for labels. Prediction and validation. The value that we are using over here is logistic regression predict X valid. This method gives a hard classification prediction, either 0 or 1, for sample in X valid. It tells you the predicted class for each data point. And then predict proba method. This gives the probability that each sample belongs to a positive class. It is class 1. Logistic regression predicts probabilities for both classes, and here we are extracting the second column, index 1, which is the probability of class 1. Once we are done with this, we are going to see the accuracy. So accuracy is a common metric for classification tasks, defined as the proportion of correctly predicted samples over the total number of samples. So we can define it as number of correct predictions by total number of predictions. This metric is useful when the dataset has balanced classes, which means similar number of samples in each class. However, accuracy can be misleading for imbalanced datasets where one class dominates the others. For example, if there are, say, suppose 100 samples and 90 are for class 0, while 10 are for class 1, always predicting class 0 would give you 90% accuracy, even the model is not learning anything useful about class 1. Now we are going to move ahead about ROC AUC curve, which is nothing but receiver operating characteristic area under the curve. It measures the model's ability to distinguish between classes. In this case, we have class 0 and class 1. The ROC curve plots the true positive rate recall versus the false positive rate at different classification thresholds. AUC represents the area under this curve and a higher value close to 1, which means the model is better at distinguishes between the two classes. Here we are interpreting AUC as zero point 0.5, which means the model is no better than random guessing. If area is equals to 1, the model perfectly separates the classes. And if it is 0 less than zero point 0.5, the model predicts a worse than random guessing. Then we are going to use the confusion matrix. It is a summary of the prediction results on a classification problem. It shows how well the model predicted the true labels by comparing predicted values against actual values. For binary classification, the confusion matrix looks like this. So true negatives, false positives, true negatives. So true negative is correctly predicting as class 0, false positives incorrectly predicting as class 1 when true class was 0. False negative incorrectly predicted as class 0 when the true class was 1. True positives correctly predicted as class 1. Then we are going to create the classification report. In the classification report, what it does is it provided detailed metrics of each class, which includes precision, which measures the accuracy of positive prediction, how many predicted class 1 were actually class 1, which is total positives plus false positive by total positives. And recall, also known as sensitivity or true positive rate, measures how well the model captures all the true positive cases. And it can be defined as total positive plus false negatives by total positive. So F1 score would be the harmonic mean of precision and recall. It is useful when you want a balance between the two. So it can be written as 2 into precision into recall by precision plus recall, and support the number of actual occurrence of each data set. Then, after having all this code and training the model, I am just defining the summary of the metrics. This is the summary. So, accuracy gives a simple measure of correctness but can be misleading for imbalanced data. ROC AUC gives a broader understanding of model performance, especially when classes are imbalanced. The confusion matrix helps understand the types of errors, false positives and negatives the model is making. The classification reports provides more granular insight through precision recall and F1 scores, making it easier to judge performance per class. Now, as we have already completed about regression, we are going to move ahead the next model that we are using, which is KNN. KNN is K nearest neighbors, and it is an algorithm used for classification and regression tasks. It calculates the distance between the points, and then by majority voting, it selects in which class the data might fall into. Do not repeat the accuracy and ROC, AOC, and you may highlight the output numbers. So the exact process is exactly same that we are doing. It's just in the. Just give me a second, Aneerban. Can you move up
Yeah,
a
sure.
little bit?
I'll show the output.
Yeah. So we are doing the same thing, but we are using KNN model over here. And in this case, the accuracy is different as we have seen in logistic regression. So in logistic regression, we have seen that the accuracy was uh, 89. Can you show that?
Yeah. In logistic regression, it was 89.
89. And when we are using KNN, it is 87. So as per both the models, we understand that preferably, although they are similar, but preferably we can go ahead with logistic regression. Um, I would like to conclude it over here. Like, hence, we can see that our model correctly predicts the default rate of customer, which is an important area or factor through which credit score is determined. And as I have already told, logistic regression has a better performance in this case, as we saw, and we can use the same to deploy large models. I hope this video explained explanation helped you to understand our project. Please feel free to comment your view and queries you might have regarding this. Thank you and goodbye.